one of today's most distinguished and advanced physicists, Michio Kaku, has recently shared his insights on a groundbreaking discovery in astrophysics. Kaku, renowned for his significant contributions to both classical experimental physics and quantum mechanics, has confirmed that the James Webb Space Telescope, JWST, has identified 6 massive galaxies that were previously thought to be impossible according to our current scientific models. This revelation holds immense potential to expand our understanding of the universe and challenges some long-held assumptions in cosmology. As such, this development is generating widespread excitement within the scientific community, and many are closely following its implications. Michio Kaku, a physicist of Japanese-American descent, stands out as a leading figure in modern science. Unlike some of his more conservative and skeptical peers, Kaku has shown openness toward revolutionary findings. He has responded enthusiastically to the results produced by the JWST, which has been heralded as a technological marvel in space observation. Kaku's decision to speak publicly on these findings signifies their importance. He emphasized that this discovery has been one of the most captivating events in recent astrophysical research, suggesting a turning point in how we perceive the cosmos. Throughout his career, Kaku has remained receptive to new scientific theories, fully aware that the traditional frameworks established by Einstein's relativity and Newtonian physics might be insufficient to fully describe the intricacies of the universe. The new discoveries made by the JWST may enrich our current scientific knowledge, although many of his peers have struggled to accept this new paradigm. This has sparked unease among both supporters and critics of the Big Bang theory, leading to intense debate. Despite the controversy, Kaku appears amused by the resistance, viewing it as part of science's natural evolution. The JWST has detected 6 galaxies that date back to the earliest epoch of the universe. Astonishingly, each of these galaxies contains more stars than our own Milky Way, despite forming only 200 to 700 million years after the Big Bang. The team of astronomers involved in this discovery has nicknamed them universe breakers, because if confirmed, their existence could upend our entire understanding of cosmic formation. According to the Big Bang theory, the early universe was a chaotic, hot environment. It was believed that it took hundreds of thousands of years for the first atoms to form, followed by hundreds of millions more before matter condensed into stars and galaxies. The appearance of well-structured and luminous galaxies so early challenges this model significantly. Some of these galaxies are not only larger than the Milky Way, but also far more active, forming hundreds of stars per year, compared to the Milky Way's more sporadic star formation. The exact timing of the first galaxy formations remains a mystery. The prevailing belief was that single stars or small groups slowly merged over time to form dwarf galaxies, which then coalesced into larger systems. However, the newly discovered galaxies suggest that large, well-organized galaxies may have formed much earlier than previously thought. This could imply that the universe is either older than we estimate or that stellar and galactic evolution occurred at an unexpectedly rapid pace. This development poses a serious challenge to conventional science, which still clings to the older models. Some branches of physics have outright rejected the findings, questioning whether they stem from observational or calculation errors. Kaku, however, is well aware of this resistance. He points out that many outdated theories have persisted not due to their accuracy, but because of the reputations of the scientists behind them. Only crucial experimental evidence has the power to invalidate these long-standing models. In physics, it is often the work of experimentalists that keeps theorists grounded, reminding us of the importance of data-driven science. Our understanding of the universe's beginnings remains limited. The Big Bang theory, first proposed in 1927 based on observations of an expanding universe, posits that the cosmos originated from a singular point and has been expanding ever since. Initially, this concept was difficult for people to accept, as it contradicted the prevailing belief in an eternal, unchanging universe. Even today, scientists grapple with the implications of a universe that has a beginning, and potentially, an end. The latest discoveries made by the JWST, however, seem incompatible with key aspects of the Big Bang theory, suggesting that a re-evaluation of our cosmological models might be necessary. Science is a process that thrives on new information and evolving perspectives. Throughout history, deeply entrenched beliefs, such as the idea that stars were fixed in the heavens or that the Earth was the center of the universe, were eventually overturned through observation and innovation. Today, we know that everything in the cosmos is in motion. Planets orbit stars, stars move within galaxies, and galaxies themselves race across the universe. The challenge for modern scientists is to remain open to uncomfortable truths and recognize that theories remain provisional until confirmed by rigorous testing. The Big Bang theory gained traction when Edwin Hubble observed that galaxies were moving away from each other with their speeds proportional to their distance from Earth. This phenomenon, known as Hubble's law, supported the idea of an expanding universe. Additional evidence came from the cosmic microwave background radiation and the redshift of light from distant galaxies. Still, it's crucial to remember that past misconceptions, like the belief in a flat Earth or a geocentric universe, were once supported by the evidence available at the time. Only later did improved technology provide a clearer, more accurate picture. We now find ourselves at a similar crossroads. Scientists expected the James Webb Space Telescope to validate existing Big Bang-related assumptions. Instead, they encountered 6 massive galaxies that defy those expectations. This underscores the dynamic nature of science and the importance of remaining open to new discoveries that may require us to rethink long-standing theories. One key tool in cosmological research is the measurement of redshift, which relates to how light from an object changes as it moves relative to the observer. This is similar to the Doppler effect, where the sound of a car engine changes pitch as it moves toward or away from you. Light behaves the same way. When a light source moves toward us, its light shifts toward the blue end of the spectrum. When it moves away, it shifts toward the red. By studying this redshift, scientists estimate distances and velocities of celestial objects. However, minor errors in these measurements can have major consequences. The techniques used to determine redshifts are currently under scrutiny, and researchers are re-evaluating their results to ensure accuracy. In light of recent findings, the scientific community must critically assess whether these surprising galaxy observations are due to redshift calculation errors or whether some researchers are simply resisting inconvenient facts. This situation calls for thorough analysis and methodological review. Thank you for watching this video and for your interest in this remarkable development in astronomy. If you have questions or thoughts, feel free to share them in the comments section. Don't forget to like, share, and subscribe to stay informed on more fascinating scientific content. See you in the next one.